Hi, welcome back to Priya's Maths classes. And today we shall study a little more about quadratic equations, as in the nature of the roots. Alright, this video is really different from the previous ones. Why is it different? See, you can see that I'm using a blackboard. Well, a blackboard is a maths teacher's best friend. Now there are many reasons for that. I find a blackboard more appealing because it's eco-friendly. We don't use it's very natural, like, okay, we're not using any artificial resources, everything from nature. A blackboard, chalk, all right, and it's very basic and it's very humble. That's why I like the blackboard. All right, so going forward all my sessions would be using the blackboard. So let's get back. So studying about the nature of the roots, let's consider the quadratic equation ax square plus bx plus c is equal to 0. Alright, that's a basic quadratic equation. We have spoken about it in the previous sessions. A, B, C are real numbers and A is not equal to 0. Condition satisfied. And I also spoke about the discriminant D. D is equal to B square minus 4AC. This B and the A and the C from here. Alright, so this D is called as the discriminant. And it can mean a lot. Yes, it means a lot. What is it? What do I mean by this? Well, we have seen different methods of, solving a quadratic equation, all right, and arriving at the solution, the roots. But without even solving for x here, by just looking at the value of d, okay, I can understand, or I can get to know something about the nature of the roots beforehand. Okay, in the sense, I can also know, I mean to say the nature of the solution. All right, whether the roots are real, and if real, are they real and equal, whether they are rational or irrational, or whether they are imaginary. Now, what's imaginary? They are imaginary in the sense the roots do not exist in the real system. Let's have a look at this table now. Okay, in the first column I have d. So as in the permissible values of d, what all values d can take. And here I have nature of the roots, namely alpha and beta. Only two roots because it's a quadratic. Now let's say d is 0. It's a straight 0. That is b square minus 4ac equates to 0. So what happens? The roots are real and equal, identical, as in alpha is equal to beta, right? So the roots become equal when d is 0. Because minus b, if we go back to Shridracharya's formula, minus b plus or minus root of d. So the plus or minus root of d, right? So when d is 0, there is no question of plus or minus there, right? And each of the roots becomes equal to minus b by 2a. We have minus b plus or minus root d, the whole thing divided by 2a. The d component is gone because it's 0. Alright, and each of them becomes equal to minus b by 2a. And if d is negative as in less than 0, the roots are virtual or imaginary. Okay, so the roots are there, but they are imaginary, as in they don't exist in the real number system. We cannot represent them on the real plane. Okay, that's a different concept altogether, which I will take up later in my forthcoming sessions, complex algebra, complex number systems. But for now, it's this. So when d is less than 0, it's negative. The roots are virtual or imaginary. Coming to d being positive, and d is greater than 0, we say d is positive. The roots are real and unequal. Okay, so it's positive. It's not 0. It's greater than 0. Something greater than 0. The roots are real and unequal, and alpha is not equal to beta. It's okay. This is when d is positive or greater than 0. Now there are two subcategories under this. One is if it's real and if it's positive, d can be a perfect square or it may not be a perfect square. What are the perfect squares? 1, 4, 9, 16, 25, 36. Isn't it? 2 2s are 4, 3 3s are 9 and so on. So all these are perfect squares. If d happens to be a perfect square, the roots are real and rational. And if d is not a perfect square, as in it is not 1, 4, 9 and so on. If it's something like 3 or 5 or some decimal or some other numbers, anything else we can say, apart from a perfect square, the roots are real and irrational. Don't worry if you're not really familiar with the difference between rational and irrational. We can see that later. But now you can understand if d is greater than 0, as in d is positive, the roots alpha and beta are real and unequal. Alright. Okay, now let's get back to ax squared plus bx plus c is equal to 0. We spoke in terms of d, or the discriminant. Now what if b is 0? A is anyway not 0. What if b is 0? Alright, if b is 0, what happens? Ax squared plus c is equal to 0. X squared is minus c by a. Now when will this be positive? We have a minus outside. If c divided by a has to be positive, but if c divided by a has to be positive, either both are negative or both are positive. So what happens if c is positive, a is negative, or c is negative and a is positive? So whatever I have circled here, this will be negative, and minus into minus is plus. So when c and a are of unequal signs, then this minus into minus will be plus. So x squared will be positive. Then we can say x is equal to plus or minus root of minus c divided by a. The roots are real. They are equal in magnitude but opposite in sign. Okay, like if 3 is a root, if say alpha is 3, beta would be minus 3. Likewise, if alpha is root of 2, beta would be minus root of 2, and so on. For this, see, we should take care, because b is 0, we should take care to see that c and a are of opposite signs, different signs. If c is positive, a is negative. If a is positive, c should be negative. Alright, and then this product will be positive, because we cannot define a square of a we don't have the square root of a negative number. Okay, square of something cannot be negative. So minus is outside, so this has to be negative, so that minus into minus becomes positive. Alright.